today, the topic of the presentation is a simple guide to optimizing your art inside of Unreal. Now, every once in a while, Epic will release some really cool assets for you to use in your project. Actually, right now, they released the Paragon Assets. To access those assets, all you have to do is go to Library, Marketplace. Wait a little bit. To the free section. And you will find all the assets you can use. So this $12 million worth of assets for you to use in your game. As long as it's an Unreal Engine 4 game, you can ship it and release it. You can dissect it, modify it, but you cannot resell the asset as is, of course. It's not just Paragon assets. So they've released the Infinity Blade assets for mobile, the Kite demo asset for open world cinematics, the materials from the McLaren demo for cars, basically, the Soul City, and there's so many more examples for you to use. Now, the thing is, those projects are usually optimized for a certain platform. Like the Paragon assets are made for high-end PCs and console. And I keep seeing beginners use those assets in their small projects and then wonder why they have a drop in performance. So today I'm just going to go over a few techniques to optimize those assets and use them for almost any projects right inside of the engine. So I'm going to switch to a project that I already prepared beforehand. And this scene is actually from the starter content. It's called the Advanced Lighting. It's a very simple scene, empty, and it has HDR lighting. So you can drag an asset and it has good lighting. So the first example is LOD. So if you're in the gaming industry, I'm pretty sure you're already familiar with the LOD. However, you don't have to generate them using a third-party software. You can do that right inside of the engine without any plugins. It's built in. So this rock is from the Kite demo. And if I go to the static mesh editor to get more information about it, we're going to see that it's around 15K polygons. So, which is good. However, that's not ideal, especially from a distance. So if we go to, we change the optimization view mode into quad overdraw. It shows me how many polygons I have on screen. Right now it's fine, there's enough, but as I go away, you see it's turning red, green I meant, and even further in distance it might become a little bit higher. Now in this case it's fine, it's not that heavy, though there's a way to optimize it even more, which is LOD. LOD is basically replacing this mesh with a lower resolution one based on distance. To create a lower resolution one, all you have to do is go to the static mesh editor and select a preset, like level architectural, small prop, large prop, deco, vista, foliage, or high detail. The closest one here is the large prop. I'm gonna hit yes and wait a little bit, and basically it's done. So you don't notice any difference. Though if I step away, you notice that the polygon count dropped actually 15K, then 7K, 3K, and we barely see any difference in the mesh itself. Maybe if I switch to wireframe mode, this will be more apparent. Oh, sorry, a little bit slower. Here we go. Okay, see that small pop? Basically it. Anyway, so all I had to do was select an LOD group and it automatically generated the ideal setting for this. However, if you don't find a setting that fits you, you can always just modify those for a certain LOD. So if I go to LOD 1, for example, I can change the reduction setting, how many % of triangles based on the distance, etc. So to show the difference, I'm just going to place the asset next to each other, and I'm going to manually specify the LOD level. So I can go to the mesh settings and hit LOD, and I'm going to force the LOD. So if I hit 1, it's the highest one, and if I put 4, it's the lowest one. And side by side, they look identical, even though this polygon, this mesh is around 15K polygon, and this one is only 1K, I think so, around that number. So we can actually use that model for mobile games, and it looks good. And all you have to do is just remove the other LOD levels, so you can remove the highest LOD and keep the lower resolution one. That's it. So another technique would be material baking. So sometimes the material itself can be heavy, not the mesh. So if I also switch to the optimization viewport and go for shader complexity, you can see that the material itself is a little bit red. So it's not that heavy, but it's still heavier. So how can you actually reduce that? Again, I'm just going to go to the material. So if I double click here on the main material and go to the parent one, just wait for it to compile a little bit. Now, if we see this graph, it might look a little bit complex. So it's only made of very simple equations as just lerps and multiply. So it's very basic. There's just so many parameters for you to customize. So you can change the color, you can change the repetition, the depth, etc. So it's very easy. However, if we go into stats, we can see that this material is 291 instructions. So now, to be honest, this material wasn't that heavy. I added a node, a noise node that's quite heavy, just to actually, for the purpose of this example, to show you how we can reduce that. So ideally, what you want to do is not bake the entire material, just look for the heavy node and see if you can fix that. Like the noise node, it's dynamic right now. So every frame, you calculate noise all over again. And we don't need that. The noise I'm using, it creates some subtle variation in the color here between two colors. And to be honest, I can get away with just using a static noise in this case. Anyway, to bake out the material, all we have to do is go back to the mesh itself, right-click, edit static mesh, and there's a button on the top right for baking out material. So if I click it, it asks me what type of material is it? Is it translucent or is it opaque? So it's opaque. And what type of texture you want to bake? So we have the diffuse one, metallic, roughness, normal. And then we have the texture size, so which is the resolution. Now, something to note that this mesh itself, it has 3 materials. So if I hit bake out, it's going to bake all 3 materials. A workaround would be to have a mesh that only has 1 material applied. If you don't have any, you can simply drag a sphere into the scene and right-click, convert to static mesh. I'm just going to go to the low-res folder and I'm going to name it simple sphere. Hit OK, and here it is. So I'm going to apply the material we had. So I'm just going to copy-paste it. And now when I hit bake out, I'm going to select, we want to bake basically the diffuse one, the metallic, roughness, specular, and normal. And I'm going to bake it at 2K resolution. Just wait for a few seconds, and it's done. So now we can actually find the newly created material, and it's here in the low-res folder. And those are the textures we just created. If I double-click, it's using a default material from the engine. I'm just going to create a new basic one. So new material, I'm going to name it perforated. Here we go. And then I'm just going to drag the textures. So it's the diffuse one. This one is black, so I'm not going to use it. The normal map, the roughness, and the specular. Since it's not metallic, so it's black, so we don't have to use that texture. I'm going to put 0 instead for the value of metallic. Connect the diffuse. So the material looks simple, but doesn't mean it's actually optimized. The best way to find out is just look at the instruction count. And currently it's 116 instructions. 1 second. It looks very reflective. So I think I messed up the 2 textures. Yeah. Okay. Hit apply, and now I'm just going to put them side by side for comparison. So I'm going to delete this object, hit the Alt key and drag to duplicate. And now the new material, I'm going to apply it next. Now let's see in full screen. So from this angle, they look identical. Though if you switch to the shader complexity view, One is green and the one is a little bit reddish. So this one is much more easier to calculate. And so what did we lose? Basically, if we go closer, you can see here the perforation. They have some parallax effect, while here they look a little bit flat. So basically, we lost the parallax occlusion because we baked the entire material. And in this case, what we could have done is just bake out some part of the material, especially the noise node, because it's more expensive, and leave out the rest. Okay. So this is how you can optimize the material itself. So optimize the static mesh first, and now the material. And let's see other techniques of how we can gain some performance. Let's go back to maps. And now geometry grouping. Okay. I want to create a pile of rocks. So to do so, I started with a base for rocks from the Kai demo. Now, those rocks are already low resolution and very optimized. So if you look at them, the wireframe is good. So I'm just going to create a pile of rocks. This rock is a little bit big, so I'm just going to make it a little bit smaller. And then I'm just going to create multiple variation of those. So copy paste. I selected the 4. I'm just going to duplicate by holding the Alt key, rotate a few, and then copy paste multiple times. Now the engine can easily handle a lot of meshes and polygons, so I'm just going to create just a multiple bunch. Okay, I think this is enough. So I can select all of them from the word outliner. So the static mesh here. Here we go. Yeah. So what I'm going to do is I'm going to enable physics simulation on those assets. So if I hit simulate physics and run the simulation, nothing happens. Oh, I hit the wrong checkbox. Sorry. I hit simulation generate something else. Okay. Gonna select those again. Here we go. Yeah, it's simulate physics. Here we go. And simulate. Now, the rocks didn't actually stay on top of each other, so what we can do is modify the simulation setting and increase the dampening. So in the linear dampening, I'm just gonna put 0.1, hit simulate, and now maybe increase it a little bit more, maybe 0.5. Here we go. And this is the nice pile of rocks. So if I hit K on the keyboard, it will actually save the position of the current boxes. So I can hit stop, it will keep them. I'm just gonna delete the extra rocks that we're not using. And I think this is good enough. So I'm just gonna reselect all of them. And so I don't keep selecting them each time, I'm just gonna group them. So group, basically. Here we go. Now this is nice, but we have around 50 rocks. So we're paying basically 50 draw calls for each material. And a simple way would be to right click and convert into static mesh. However, what this is going to do is going to combine the meshes, but it will keep all 53 materials. So another way is to actually use merge actors. And merge actors, we have multiple settings. I'm just going to start with the first one, which is grouping. And when I hit merge actors, I'm gonna navigate to the low-res folder and call it pile of rocks. Here we go. And save. Done. Okay, so if you check out the static mesh, it has 4 material, which makes sense because we started out of 4 rocks. So it's 4 materials that have been duplicated up to 50 times. Now, there's actually another settings we can change to combine the material themselves. So if I hit right click as well, go back to the merge actors. And this time I can select to merge the material. It will work, though first I need to make sure I'm selecting the LOD level. And a specific LOD, so I'm using the first one, the highest resolution one. And now I'm gonna hit merge material. Same, I'm gonna go to the lab, low res. Underscore merged, basically. Hit save. Wait another minute, and what it's going to do, it's going to create an atlas of the textures. So basically, it's going to show 4 textures in one, and merging them into a single material. So this is an atlas, basically, all 4 textures. And now if you check out the new pile of rocks, if we go to static mesh, it only has 1 material. So let's put all 3 next to each other to compare. So this is the pile, and this one is the merged one. And they look identical, again, from this angle, though if I get closer, we can see that this one is a little bit lower resolution. And that's because we basically took the 4 textures and we put them into one, so we lost 1/4 of the resolution. But as well, the original material, if you go back to that one, I'm just going to open the group so I can select one of them. If you go back to the original material, it's using texture detail. So what it does, it's actually taking another texture and it's styling it on top to create more details on it. Here. Now, an interesting case in this example is that all 4 rocks are child of the same parent. So all of them are using this master material and the same texture detail. So a simple trick we can do, and again, it's case by case. So right click, create a new material. I'm just going to create pile of rocks. And I'm going to take the merged one. So I just installed a few filters on top, so I can just easily select the texture and the material. So we have the normal and the diffuse color. Sorry. What I'm going to do is basically take the original mesh we have, that's the instance material, and I'm duplicate it. So right click, copy into the low-res folder. Here we go. And this time, instead, I'm going to put the diffuse and the normal, the one we merged here. So the merged one, here we go, that's the diffuse, and that's the normal. Now, there is a setting to keep in mind, which is the brightness. So here we have a setting called darken. We just need to put it back to 1. Actually, 0 out. Brightness 1. Cool. Yeah, put the brightness back to 2. There we go. It's because the texture is already darkened when we baked it, so we want to darken it again. And now, if we take the merged pile of rocks, same one, and we apply the new material we created, we end up with the same object. However, one of them is more detailed. When we get a closer look, we can see all the details here. So we gain back the resolution. So we just created a new asset, a pile of rocks. It has single material. It has the same original parent, and it's only one draw call. And we didn't actually use another software to do all the merging or all the baking. It's all done inside of Unreal. Okay. Now, the next point is instancing. And this one is fairly simple. So if you're not familiar with instancing, is when you have a same mesh, but you're using it multiple times in a single frame. So right now, I'm looking at the same rock multiple times. I don't have to render it and load it to the GPU multiple times for that frame. I can specify that all of these rocks are an instance of each other. So what's going to happen, it's going to load it once, and then it's just going to render it multiple times. So hence, it will only cost you 1 draw call. So to do so, first I want to show you how many draw call we already have. So there's a command for that, and it's called RHI. 1 second. It usually works. Okay, 1 second. Yeah, I think it's just because I'm in the view here. Oh, I'm opening the wrong command prompt. 1 second. It needs to open on the top. Okay, I'll go back to that in a second. But for now, so I usually list how many draw calls we have in the scene. So I'm just going to select all of these rocks from the word outliner on the right. Hit right click and then go to merge actors. And this time I'm going to switch to the second tab where you can actually group them by instance. Okay. So if I hit merge actors, it will basically hide the original ones and replace them all with a single blueprint that has all the rocks. So basically they are all grouped and they cost only, it's like one instance. However, there is a limitation for this technique where I cannot control one rock individually. So a trick to that would be once you want to move a single rock inside of the gameplay, you can just remove that rock from the pile and then spawn a new one that's individual that you can control. That way you only pay the cost for that extra rock and not for the entire bunch. Okay. Here we go. And nope. Okay. So next level, and this is the most recent technique basically. It's been used a lot in Fortnite. And it's actually fairly new. And what's interesting about this technique, it's really topologize the entire asset and optimize it all together. So let me show a simple example. This mesh is from the Paragon Assets. And it's actually made out of 3 elements. So this is the first one. This is the second one. And this is the third one on the back. Now also, this mesh is very high res. And if I get closer, it also has some faces in the middle where we can't see them. Like take this sphere, for example. If I take this sphere and drag it all the way inside of the mesh and adjust it a little bit. Okay, so now we can't see it at all. So there's no use in actually calculating that mesh. So I'm going to select all 4 meshes. 1, 2, 3, and 4. There's a way in Unreal, what it does, it will voxelize the entire mesh, it will recalculate the entire faces, remove all the extra faces, rebake the textures and the materials into one, and all of it in a click of a button. So I'm just going to right click, and again, I'm going to go to the merge actors, and this time I'm going to go to the new proxy tool. So we have the screen size. Screen size is basically how many pixels on screen the object will occupy. So probably this object will be a little bit in a medium distance, so it will occupy around 200 pixels on screen. So I'm just going to write that. And basically what it's going to do is going to calculate the ideal settings for creating the new mesh. Now it's going to ask me how many, what's the texture resolution you want. So I think 2K is more than enough. And I'm going to bake a metallic map, a normal map, roughness, and specular. That's it. I'm gonna hit merge, go to the low res, and this will actually take a little bit of time. So we're just gonna have to wait. It takes around a minute or 2, basically. Cool. However, if we're running short on time, I can close the project and open a version that's already finished. But I'm going to give it a minute just to do so first. So this tool is only available in Unreal Engine 4.20. It was in 4.19, but it was experimental. Yeah, that's basically it. In the meantime, maybe I can take questions.
Regarding the basing of the Atlas texture, do you also calculate an optimized packing for the UVs, or you just take the four existing UVs and basically put the bounding boxes one next to each other?
Yeah. So yeah, it does exactly that. It's going to take all textures and place them next to each other. It's not going to remap the entire UVs and optimize the spaces in between.
Okay.
Yeah.
Thanks.
Cool. So any other questions? I can't see anything. It's pitch black in front of me, just saying.
No more questions.
Okay, then I have a recap presentation because I explained multiple techniques and I'm just going to quickly go over them. So the first one was LOD. So you have a polycruncher right inside of the engine. It can remove polygons without actually changing geometry that much. And right now what you're looking at is this LOD 0 till 3 and all the meshes look actually identical. Now it is specific for this case where the asset itself was made for cinematic. So it wasn't that much polycrunch at the beginning. However, if you have already an asset that's optimized for mobile, like if you take the Infinity Blade asset and you crunch it, you probably won't see that much polygons left from the mesh because it's very low resolution at all. Anyway, so we have baking materials. Just bake whenever you think you need to bake. So don't go out and bake every single material inside of your project. Use the profiler, for example. Find your bottleneck or use the complexity view, shader complexity view. It will let you know, like this shader is very heavy, it's red. So you go there and you optimize it. And you also have the geometry basically grouping. And this is when we grouped all the material and the object and the static mesh into a single one. And instancing. So instancing is when the same object is used multiple times in the same frame. And in this picture, there was 105 rocks. We reduced basically 104 draw calls from the calculation process. And finally, there's this mesh. So once it's done, you're going to see that the difference is quite minimal. The only difference, for example, you might notice if you get closer, you can see the moss here is a little bit less sharp. However, from this distance, it's perfectly fine. And the first mesh was around 105K triangles, while the second one is only 1.6. And it was 4 meshes, it's 1 mesh. It was 6 materials, it's 1 material. So we just created, we took an asset that's super heavy for console, and the optimization we made, it can actually possibly run on mobile. So yeah, you can use those techniques, take the Paragon assets, and create mobile version of Paragon, basically. And there's a lot of Rice streams on how they did the optimization for Fortnite, so you can check those out, and they will help you also get to know which settings to tweak as well. Now, in Fortnite, they use this tool to reduce buildings. So if you're playing on mobile and you look, there's a city way in the background. They used this tool, and what it did, it merged all the buildings into a single mesh. And what's interesting is that it also removed the interior of the entire building. It closed all the windows, closed all the doors, all the gaps, and an entire city can be less than 1K, basically, less than 1K polygon way in a distance. However, if you use a polycruncher, you won't get the same result. You'll get a big blob, basically, because polycruncher just removes the polygons based on angle. It doesn't know which polygon is in front of you, which one is more important than the other. So, yeah. And before adding this tool, you had to buy a subscription for a plugin to actually do this process. However, now it's built in right into the engine. So all of the techniques I showed today, none of them are using any plugins. Everything is built in. And yeah, that should be like a few tricks for you to quickly optimize your game. And yeah, thank you for listening.